A 5-liter flask containing 10 grams of iodine vapor is filled with 10 grams of fluorine. When the reaction is complete, the temperature of the flask is 125 degrees Celsius. What is the mole fraction and the partial pressure of the product? This chemistry problem integrates many concepts, and it's the type of problem that appears on the AP Chemistry exam. I'll solve this problem assuming the viewer has a basic understanding of the chemistry concepts involved and how to use significant figures. The problem is asking about the product, but no chemical equation is given. Therefore, it has to be deduced. The two halogens, iodine and fluorine, react to form iodine pentafluoride. This is one of several chemical reactions that should be committed to memory. Balance the equation and proceed with the problem. Finding the mole fraction of the iodine pentafluoride cannot be done without knowing the total moles in the flask, specifically at the end of the reaction. That's all calculated using stoichiometry. I need to determine the limiting reagent since that determines the amount of iodine pentafluoride. Convert the 10 grams of iodine to moles. Then multiply it by the mole ratio between iodine pentafluoride and iodine. Repeat this for the fluorine. The smaller amount of iodine pentafluoride comes from the iodine, which means it is the limiting reagent. The amount of iodine pentafluoride produced is the theoretical yield. This is the amount present when the reaction is over. Iodine being the limiting reagent makes fluorine the excess reagent by default. The leftover fluorine at the end of the reaction contributes to the total moles and must be calculated. Again, do this with stoichiometry. Take the theoretical yield and multiply it by the mole ratio between fluorine and the iodine pentafluoride. The result is the amount of fluorine used in the reaction. Now this amount must be lower than the initial amount. If it's not, recheck your math because there's a mistake somewhere. Subtract the amount used from the initial amount to calculate the leftover fluorine. The sum of the moles of the iodine pentafluoride and the leftover fluorine equal the total moles in the flask at the end of the reaction. The mole fraction of the iodine pentafluoride is then the quotient of its moles divided by the total. Moving on to the partial pressure. The partial pressure of iodine pentafluoride depends on the total pressure inside of the flask, which we don't know. Since it's a gas, use the ideal gas law to calculate it. The volume of the gas is that of the flask, 5 liters. I just calculated the total moles. R is the ideal gas constant, and the temperature is that of the flask at the end of the reaction, but don't forget to convert it to Kelvin. Plugging these values into the ideal gas law equation gives a total pressure of 0.948 atmospheres. The partial pressure of the iodine pentafluoride is the product of its mole fraction and the total pressure. If you have any questions about this video, please leave them below or on my Twitter feed at iTutorChemistry. Thanks for watching.